Hello, hello. This is part 2 of the series on 2.5, find the domain of composite functions. So composite function is like f of g of x. So finding the domain is a little tricky, so we're just going to focus on doing that. So this picture kind of illustrates what's going on. So in this purple region over here, alright, that represents everything in the domain of g, the inside function. So it starts off with anything in the domain of g. And then what comes out of g is the range of g of x. And then everything that comes out of the range of g of x must be able to be taken on by the domain of f of x. And that's how you find the domain of f of g of x. Easier said than done, but watch and learn. So, find the domain of f of g of x if g of x is 2x plus 5 and f of x is 3 over x minus 2. Alright, so we're first going to start off by finding the domain of the inside function. So that's a linear equation. So the domain of g would be x belongs to the set of all real numbers. Now, we don't really, we care of what the domain of f of x is. Alright, since it's really 3 over x minus 2, the domain of f of x would be x cannot equal 2. Because if it did, then we'd be dividing by 0. But remember, what goes into x first goes into g. So whatever x is goes into g, gets multiplied by 2, and then 5's added to it. Then it goes into f, because it's f of g of x. So whatever's going into f, you just have to make sure it can't be 2. And what's going into f? G of x. So what you do is you simply take the range of g of x, which is what g of x equals, 2x plus 5, and say that can't equal 2. And then solve. Because again, f of g of x is really just 3 over 2x plus 5 minus 2. So we have to make sure this doesn't equal 0, which is the same thing as solving for this. 2x plus 5 can't equal 2. So you subtract 5 and you get 2x cannot equal negative 3, and then you get x cannot equal negative 3 over 2. If you plug that in here, you would have a domain restriction. Let's try another one. Let's find f of g of x if f of x is x squared minus 9 and g of x is root 9 minus x squared. Alright, so first, right, this is the same thing as f of g of x. So we have to make sure whatever x is can be taken on by g. Now the domain of g of x is all real numbers between 3 and negative 3. Because if you solved the inequality 9 minus x squared is greater than or equal to 0, that is what you would get. All real numbers between 3 and negative 3. Alright, so now what comes out of g of x is the range of g of x, 9 minus x squared. And you have to make sure that this can be taken on by f of x. Well, luckily, in this case, f of x has a domain of all real numbers. So whatever the range is of g of x, like whatever, after you plug something in for x, and then whatever comes out of g of x, it'll be able to be taken on by f, because the domain of f is all real numbers. So, in other words, we have to make sure that root 9 minus x squared belongs to a set of all real numbers, and it will, as long as you're plugging in values from that domain. X is in between 3 and negative 3. So, your final answer is the same as the domain of g of x. It's just all real numbers between 3 and negative 3. That would be the domain of f of g of x. Now here, if we do g of f of x with the same two functions, it gets a little more tricky. So, now, same functions, but we're doing g of f of x. Alright, so this right here is the same thing. When we write g of f of x like this, is the same thing as g, and then inside of that f of x. So first, what can you plug in for x? Well, the domain of f of x is all real numbers, so we have nothing to worry about there. Then, what comes out of f of x? Well, the range of f of x, all the y values of f of x, for any real number, can be defined as x squared minus 9. Now, remember, the domain for g of x was x had to be in between 3 and negative 3. So we have to remember that whatever we're plugging in to f of x, it's going to come out as x squared minus 9, and then that's going into g of x. So we have to make sure x squared minus 9 is in between 3 and negative 3. And if we add 9 to all three sides here, we get x squared has to be in between 12 and 6. So how do we solve this? Well, that right there is the same thing as saying x squared has to be less than 12 and x squared has to be greater than or equal to 6. So all those things need to be true. So I'm just going to erase here so I have more room. So what we're going to do now is solve both of these. So by subtracting 12 on both sides and then factoring, using what we learned about polynomial inequalities, we get that the solution to x squared minus 12 is less than or equal to 0 is, after factoring this down to x minus root 12 times x plus root 12, we have a number line and we put root 12 on it and negative root 12. After testing points, we get that, well, if you plug in 0, you'll get a negative. So all these numbers between negative root 12 and root 12 would be a solution to just this first inequality. X squared is less than or equal to 12. Alright, but anything greater than root 12 or less than negative root 12 won't be a solution. And then, since it's and, we have to make sure both these things are true. So now if I solve this inequality, I forgot the little squared thing there, subtract 6, and then factor, so I get x minus root 6 times x plus root 6. The solutions to this inequality, I will do it in a different color, is going to be, well, if you plug in 0 now, so I'm going to put root 6 on there, negative root 6 on this number line, and root 6 on this number line. If I plug in 0, I don't get anything, I don't get a solution, right? Because you'd have negative root 6 times root 6 is a negative, which is not greater than or equal to 0. But if you plug in something greater than root 6, like 10, you'll get something that is greater than or equal to 0. So I'd shade everything to the right of positive root 6. And if you plug in anything less than negative root 6, I would shade everything to the left of negative root 6. So where are both of these inequalities true? It's on this interval that I'm going to highlight in orange, represents red and yellow, where both those are true. And where you get our answer, so the domain of g of f of x is going to be all real numbers between negative root 12 and negative root 6, and then also all real numbers between root 6 and root 12. And I know root 12 is really 3 root 2, so you should simplify that, and that is an answer. Alright, now if we look at a graph of this real quick, so I'm going to pause and pull up a graph of g of f of x. So here's a graph of the composite g of f of x, and you can see from the graph that it only spans x values from negative root 6 to negative root 12, and then also between root 6 and root 12. So a good way to check these with a calculator, see what x values the graph hits when you graph it on a calculator. Alright, hope that was helpful. See you in class.